Now, during this meetup, feel free to ask the questions. I will have my eyes on the chat window, so I will know if some important questions coming in and try to address them during our talk. Again, those who are late, we're gonna have a long presentation first, and then we'll do some coding. And basically, today in the topic, we are discussing about Python 3 and what is new in Python 3 and why Python 3. So I'm hoping that by end of this event, this presentation, you will know a lot about Python itself, Python lifecycle, how Python is being maintained. Python itself is a software, so all the fundamental software engineering life cycles also apply to Python. And also we're going to talk about why Python 3 exists, why they have to go from Python 2 to 3, like why there's Python 2 and Python 3 as a two separate entity exist, and why there's so much debate about them. And we have seen Java. I mean, Java has been around, and they never have any kind of problem with all this 2 versus 3 kind of discussion or any kind of their own version discussion. Right now, I think Java is into 9 or 10. I've been lost track of it, but they never had all these issues. Why Python has these issues where people are worried about Python 2 and Python 3 and learning about different things, why it is all broken up. So we'll try to touch base on all of those topics, and hopefully by end of the day you will of course learn some cool Python 3 syntax, see the difference. Either you are learning in Python 2 and either you're starting with Python 2 or 3, see the difference and understand it well. If you are already have Python 2 applications, you want to migrate to Python 3, some of the strategies we will talk about. So overall, at the end, when you go home, you will feel strongly about learning something good, new Python 3 stuff, maybe better than your peers. And yeah, hopefully it will be very productive for you guys. And okay, so let's get started here. So as a content, we're going to talk about a little bit about history, and then we're going to talk about why Python 3, some of the Python 2 to 3 changes, and we're going to talk about syntax that were removed in Python 3 from Python 2, new syntax being added, some conclusion and references that I used. Full disciplination. So a lot of the code and content here are I have picked up from the internet, and I have put all of them into my references. So I am not the original generator of all the content. I have assembled them and put all the references attached to those content. So uh, just discrimination, so you guys know. So let's talk about history. Who invented Python? Anyone can tell? Gadovan, if you don't, he's a Dutch guy, anyways. So Python 1.0, and so first Python version 1.x, you can say that how it started. At the time, Gadovan was he was a software engineer hired by this research institutions, and they were working on this language called ABC programming language. And one of his uh, um, Christmas break, he was get bored, and he was like, "Hey, I know this ABC programming language, and there are so many fault and so many restrictions in that. Can I do something better?" And in his part time as a hobby during the vacations, he wrote the first ever module of Python, or first ever code of Python. He already had this knowledge of writing operating system, programming language, because that's what he was doing with the ABC. So he thought that, hey, this ABC has so much baggage. Can I write a better programming language? And that's how Python started in one of his Christmas break, because that's what geeks do in their Christmas break, build the new stuff. And so the project actually started in 1989, and the first version, the Python 1.0, officially released on 1989. And that the first version of Python 1, that they released multiple release cycle, and from 1.0 to 1.6, that release cycle, that version of Python lived until 1994. So what was that in Python 1.x? Python 1.x is successor of ABC, so it's really early age of programming. You need to think about this. Like 1994, Java was not even invented. Java came around 2000. Uh, uh, so Python is like started even before Java, and started by this guy, and he was just trying to put together some nice programming language. So Python at the time had functional tools. So some of those, if you know about these functional methods, map, reduce, all those kind of some of those functional tools, capabilities, keyword arguments, and complex number support. And this was really early version of Python. No one was really using it, and it was not a popular, but it was keeping up momentum. It was picking up by a lot of people who want to do some kind of scripting. It was a fun language. And the Python and the plan for releasing Python as a Python 2.0 started around that time. So Python 2.0 to 2.7, which was the major Python life cycle, a major Python release with all kind of features. Starting from 2.0, there are all these advanced programming language capabilities like garbage collection, memory management, support for Unicode, functional programming, OOP, all those things started with 2.0 and keep evolving until 2.7. So year 2000 to 2020, up until January, this year, January, that's when the Python 2 lifecycle ended. So that was the whole, the timeline where Python 2 started and Python 2 ended. And then Python 3, so Python 3 was not direct successor. When Python 2.0 being worked on, around 2004, the discussion started that, hey, we have made this amazing Python 2.0 language, but along the way, we made so many mistakes and we need to correct them. Now, to correct that mistake, they start thinking about how we redesign some of the steps and fix all these things. Basically, that we will see what are the mistakes were there and why they are mistakes and why we classify them as a mistake in the design of Python programming language Python 2.0, and they really wanted to correct them. And there were two ways you can do if you are in a software life cycle, when you have to maintain the older versions and you want to do the new version and you want to bring some substantial changes in your, so either you can do backward compatible version or you can just break backward compatibility. Breaking backward compatibility has its own issues, that people cannot grow with your existing programming language, because if you are breaking backward compatibility, that means the let's say there's a 2.8 which has all these features that doesn't work in 2.7. So it's hard because you cannot ask people to rewrite their whole project. And if you have been working in a software industry, sometimes software can grow very huge. So there was a choice that has to be made, and they made that, hey, we're gonna start with Python 3.0, and we're gonna rewrite all this spec, and we're gonna change all these things that we have done wrong, and we're gonna fix them. And that's how 2004 around discussion started, and the first Python 3.0 was released in 2008. And up until 2012, there was so much discussion about, hey, so do we need Python 3.0, or was there a mistake of creating this separate Python 3 in backward compatible versions of Python? uh, is it a good idea? Basically, do you want to really do that? And all that discussion keep evolving, coming in. But today, as we know, that discussion is behind us, and we finally have Python 3.0 as an official support release. Today 2.7 support has ended, so there is no fixes coming in, there is no development coming in, and it's highly recommended for everyone to move to 3.0, because that is how the world is moving. Now, why 3.0? So couple of very guiding principle, or you can say North Star, what we want to do in Python 3.0 and why we want to go to Python 3.0. So the idea was reduce feature duplications by removing old way of doing things. So Python 2.0 has made so many mass of APIs in a way that you want to achieve one thing and there are multiple ways to do the same thing, and which is not a really good way to do that. There are so many other mistake that has been made in terms of performance wise. Performance is not major problem. The major problem is the syntax, because if uh, you have created, let's say, a method and it behave in certain way, and you think that, hey, this is very wrong, this method should not behave in certain way, it has to change the other way. Now think about that. If suddenly you have written a code base, let's say example, take an add which take two number and give the return addition, right? Let's say if you substantially change the behavior, hey, now add will not do 2 plus 3, it will do binary number addition. Okay, so to convert 2 into 0 and 0 1, convert 3, like your two input into 0 and 0 1 and do binary addition or something like that. So now you want to change the whole way the functions behave, and that is not possible. You cannot do that in subsequent release. It has to do separately. And we will learn more about what I'm talking about. It might be confusing here, but just think about that. Like in Python 2.0, there were so many things that were happening in a very wrong way. The there are very confusing way of introduce a lot of methods and their behaviors, and there are multiple ways to do the same thing, and all of this has to be consolidated, and there has to be only one obvious way of doing things, and that is what we need. And also remove all the ambiguity that we have around all the features. Now for the ease of transiting from 2.7 to Python 3, there has been so many features that has been backported to 2.6 and 2.7. That means there are some features that was introduced as a new in Python 3.0 and forward. You can use those feature in Python 2.6 and 7 also, because they say that, hey, although this is a new thing, we want to do it for only Python 3.2, but we're going to do some backporting. So some of the feature is available on the both side too, in the previous two release 2.6, 2.7 also. So this is a bit of history about Python. And right now we are at Python 3.0 and going forward. Now, those who are in touch with Python, they know that there's a thing called Zen of Python. You can look up online. Here's a link. It's a PEP20. PEP is a Python enhancement proposal. So how Python language evolves. So people put the proposals of, hey, we would like to add this extra fancy way of doing the for loop, or we want to add this extra crazy walrus operator or stuff like that. When you have some kind of proposal, hey, I want to change how Python's default sorting algorithm works. So any of the proposal that you have, it could be new syntax, it could be internal improvement, any of those stuffs. Python has a way to manage them. It's called Python enhancement proposals, and all these proposals are numbered. Now, up until 2018, Gadwan had he was in a way the dictator or maintainer of or had a veto power on saying that which feature will go into Python next release and which feature will not. I'll just give you a quick look about this. So I'm saying that Python PEP20 had this idea of Zen of Python. Zen of Python is ideas that when you're writing a software using Python, what are the guiding principles or guiding standards that you need to think about when you are designing or writing a code. So when you click on link, this is all. So all the Python PEP index here, you can find all those. We'll use PEP a lot as a proposal. So you can see that this is proposal number, the name, title of the proposal, who is the author, Tim Peters' status, when was created. So in 2004, this proposal was posted, and then it was accepted. So status is active. And so there are like multiple lines. You can say beautiful is better than ugly. People who are familiar with the Python and bit of history, and who are like Python geeks, they know all these things. And they have very beautiful ideas. One of those which I like most is readability counts, because I like to write the code which is very much reliable. Complex is better than complicated. So simple is better than complex, explicitly better than implicit. I hate so much implicit stuff, because I don't know why this magic method comes from where. And one of the most important thing, there should be one, and preferably only one, obvious way to do things. So there should not be too much ambiguity. If you can do something, there should be only one way to do it, and it should be very obvious way of doing things. Like, that, yes, you can read the method, you can know what it does. Like, there is no ambiguity. Even there is no multiple way to do things. There should be only one and obvious way to do things. So that is one of the Zen of Python. And there are other things, but I want to emphasize on this one, because this is one of the guiding goals why we choose Python 2.0 to 2.3. And so let's continue with the talk. So one of the line from this Zen of Python, it says that there should be one and preferably only one obvious way to do things. And this is one of the reasons why we want to do this. Python 2 had so many methods. And as I told you before, which has like multiple way to do things. Let's say for a very, very classical example, print. Print act as a statement also, as an expression also, and print act as a function also. If you say print space, whatever expression is a statement, it's an expression. But if you say print, then round bracket, and then you pass something, that is a function. So what is a good way to do that? There are two ways to do things, and which is not very useful. In multiple places, we have like two way of let's say iterating over a loop, iterating over a iterator or generator. One is lazy evaluation, one is quick evaluation. So why you want instant evaluation and lazy evaluation as a two way of doing things? There should be only one way of doing things. So that has been one of the guiding principle, and that we're going to talk about more. So Zen of Python, which is one of the source for this all this discussion. So the Python 3.0 manifesto, or the first ever release of Python 3.0, and this is a documentation that you can read here. And Godovan has said this line in that in his release note for 3.0, saying that the first ever intentionally backward incompatible Python release. So up until Python 2.0 to 2. At the time when 3.0 were releasing, I think it was 2.5 or 6, because 3.0 came in 2008. So they were like, hey, we're gonna release something which is gonna be backward incompatible, and this is what it is. And you can read about all the documents that the things that they had. This is the release note. You can see that the release date is 2009. Normally, the software pipes life cycle or release life cycle take 1 year. So you can see that any new version of Python that is coming in will be available. So first, so if you look at the release cycle of the Python, you will see that the first time developer close saying that, hey, we are done with working for whatever we spec'd out for Python 3.0, and then up till 1 year, it go through multiple phases of the software. It goes from alpha to beta, and finally it become the release candidate, and finally release. So the whole cycle is 1 year, and all the bug fixes and stuff goes on. So the release cycle of Python. We're going to talk a lot about software life cycle here, for the reason that so here when you're talking about Python 2 and Python 3, we are basically talking about software management, because you have this software Python programming or Python compiler version 2, and we have 2.x and Python compiler 3.x, and these two pieces of software or two versions of same software are incompatible, and we're going to work with both of them, and how we're going to keep supporting and how we're going to migrate. So people who are working on an older version of my software will move to a newer version of my software, and here the software being the Python compiler, Python programming language. So let me pull up this release schedule Python 3.8. So this is again proposal 589. This is 3.8 release schedule. So if you can see here, 3.8 development begins in 2018, and first of the 2018, and the final release candidate. So you can see here 2018. This is taking way more time, because the final 2019 and 2019-12, and candidate 1 gonna be 2020-01. So I'm trying to say that it comes from development to alpha 1, 2, 3, 4, beta 1, 2, 3, 4, candidate, and final. So it's a longer life cycle of software to evolve, and it evolves over time. So here, when they start with Python 3.0, they say that, hey, we're gonna create this new release which will be not backward compatible. And so now the main question that we are here, why we want to create this Python 3.0, which is why you want to create a Python software's next version which won't be backward compatible, and which gonna create all these all this debate and all this controversy about Python's and release cycle. So why you want to do that? So what was the reason behind? What was the motivation behind going for Python 3? So one, and preferably obviously to perform something. So this is the one main topic which I said before, that Python 2.0 has some single thing which was done multiple ways, and they really want to concentrate whole thing. So that's why they say that. So first thing, our programming language has to do one thing, and one way and very obvious way. So that was the first thing. Second thing, second guiding principle was lazy evaluation over instant compute. Now, there are reasons why you want to do the lazy evaluation or instant compute when you are working with the generators or iterators. I would say generators, not iterators. The first reason is, of course, is more efficient, because when you're doing lazy evaluation, you're not generating an object, keeping it into memory if you're not using them. Let's say let's say on line number 100, you have a choice to either do lazy evaluation or instant compute. Lazy evaluation will not compute the whole list for you. Instant compute will create the whole list for you. Let's say that list has a 1 million elements, and the size of that particular memory block or that particular variable will be, let's say, around 1 KB. Now you have a choice. Either you can carry that 1 KB up until it is being used. That is, let's say, line number 500. So line number 100, line number 500, you are not using that element, but you are still keeping that particular memory block, particular data in memory. Why you want to do that? You only want to create the list when you want to use it. Lazy evaluation has this idea that you only create the list, or you only generate the list, or only get the data when you finally want to use them, and not keep it in the memory, because it's not efficient, it's not ideal. Why you want to increase the memory load for that? So that's why lazy evaluation has to be done. Now Python 2, as I told you, there are so many methods. First thing, by default all the Python generators will do the instant compute, and then there is a lazy evaluation method available later stage. So we don't want to do that, have providing two methods doing the same thing but two different way using two different APIs. And so that's not ideal. And also there are so many unambiguous behavior or confused situations. So there are some variable, it says input, but when you type something in your when you say input, so basically it's a try to read the input. And when you provide the input into the Python command, uh, it is not expecting. So what you think when you say input command, you think that it's reading something that might be a string comes first, because that's how you read something from terminal. Everything that you run from terminal using programming language is normally in the form of string, right? But here when you say input, it actually read the expression. So it is expecting some kind of expression, which is could be any kind of mathematical expressions or numerical expressions, or something that you can like, it's a basically expressions they are expecting to provide something that it can evaluate and give you the answer. But if you want to read something as a pure string, you have to use something called raw input. So you see, like, there is some confusion here. Like, someone who is seeing input, who is coming from different programming language, and he see input and he's like, oh, this is input, must be asking for string. So there's so many ambiguous situation, confusing situation. And we don't think about. So when you're writing a software, you're not just writing software for the people who have read all your document. You have to assume that people who are using your software, they don't know things, they don't read documentation, and you want to provide them something out of the box. They read and they understand what it is. I don't need to look up what input does. When I read input, obviously I'm going to think about that, hey, this is asking for input, must be a string. So there's so many ambiguous behavior, and there are so many complaint or proposals saying that, hey, this doesn't make sense, or this is like very crazy weird, and all like all the debates about does Python has to do certain things like that. So many of those kind of things were getting accumulated. So all those kind of problems were like from starting 2000 to 2004, all these things were coming together, and they finally thought that, hey, we need to address all these problems. But again, we have this issue of backward compatibility, because people are using these two different ways, two different prints, two different either lazy and compute for doing their job. So now what we do, like, if you want to get rid of all these wrong mistakes, then how to get rid of all these wrong mistakes is going to be troublesome. So they say that at the time they decide that instead of deprecating them over the time, let's just create this new language and just break the backward compatibility. That was the choice being made at the time. And if you want to really read on this, PEEP 3000, it's called also Py3K. So if you go here and you type 3000, so there are two PEEPs which we start discussing about Python 3.0. So first is PEEP 3000. So all these abstract naming, and I like this part where they say, okay, so this is the proposal timeline. There's a 3000, and then another one is 3010. So it started with 3000 first, but then they ported to 3010. So all the Python 3 plans and 3.0 plans. So this talks about, hey, we want to do Python 3, and this says that, hey, this is a plan for 3.0. And So if you see, the proposal was created in 2004. So at the time the discussion started. And if you look at the general goal here, so general goal is to reduce feature duplication by removing old way of doing things. So feature duplication, doing two things, providing to do one thing, two way to do one thing basically, and remove the old way of doing things. And there are so many other, weird way of doing things, so we want to get rid of them. And the general principle of the designing will be the one obvious way of doing something is enough. So they wanna, so now that they say that, hey, now let's design this language again, and the next time when we design something, this one is going to be our design goal or design principle, one obvious way of doing something, so one obvious way it has to do something. So that's when all the discussion started. So 3100, that is where you can go and look for all the proposals and the links and how things are moving forward. So this was the modification, this was all the motivation behind going for Python 3.0. So now let's talk about some of the changes. So we're gonna look at some of the very famous, or the most the API, the change which will be impactful in most of the cases, or the certain methods and certain things that we use a lot in Python, and we're gonna see how it's gonna change when you're moving from Python 2 to Python 3. So now first, one of the thing is Python is a function now. Now we're going to type all these things, but before that, let's just set up our Python. So this is Python 2.0. Python 2.7 is our latest version, and Python 3. So in my system, I have Python 3.7. So 2.7 and 3.7, these are two versions we're going to using, and we're going to comparing what we can do and what we cannot do with the Python 2 and 3. So first thing, the first change is regarding there should be only one and obvious way of doing things, and not multiple way to do things. And the first thing is this print statement. In Python 2, this both version of print statement will work. So here's the example: print my name is Nishant, and if you say Python 2 and Python 2 in the both here with the space and here with the braces, and in both the cases it will work. But in Python 3, this has been gone. This is no longer valid now. You will see a pattern after some time. So this is Python 2. Sorry, this is a damn. So in Python 2, this is some okay. So this works here, and okay. So with the braces, it's gonna work in both the cases. So it's working fine when you are using print and then quotes and like a circle bracket. Now let's try to do this print as a statement. So this is the print as a function, because as a function, it's a function, it takes an argument. Now this is an statement or expressions. You say a plus b, right? So this is an expression. So in the Python 2, this works, but in Python 3, this will not work. So it's a missing parenthesis. So because print, it doesn't recognize what is going on here. So it is like, so it also says, do you mean print statement like this? So this is the first change. Now let's move to the next one. So print now is a function, and in Python 3, the support for print being a statement is gone. Now this is a good one, range. In Python 2, we have this function called range, which basically generate of course, a range or a list. So in Python 2, it used to be it was instant computed method. So when you say range and when you provide parameters, first is start, second is end, and third one is step. So here saying is 0, 5, 1, that is generate start from 0 up until 5, and 1 as a step. So that means like between 0 to 5, between each element, it has to be one step. So if we say 2, it will be 100, 0 to 4, if you provide the 2. So 1 is a step, third parameter anyways. In Python 2, range will do the instant range will do instant compute, but in Python 3, the range is now lazily evaluated. So it is basically giving a generator. And so in Python 2, we used to have this X range to do the lazy evaluation, but since Python 3 already, the original range is already being assumed as a lazy evaluation function in Python 3, so X range has been removed. So you will see this pattern where you have this function, they were not lazy evaluated, and in Python 3 now those instant compute method are now has a different behavior now, and those instant compute has become the lazy evaluate methods, and the alternative version of lazy evaluation that was already exists in Python, that now that is gone now, so you cannot use them. And you can see this pattern that everything in Python 2 that was instant compute has turned into lazy evaluation. So you can see there are different generators like zip, map, filter, all of them has also now converted into lazy evaluator. So none of them, when you say zip and you provide two iterator, so it will not give you the instant answer of a tuple list. It will give you generator. You have to use next to get your next element in the list. Or there's a hack called list. So let's try this out. We have this called range. So first Python 2. So in Python 2, when you say range 0, 1, it just instantly evaluate and give you like the full list. But in Python 3, when you do the same thing, it will give you range 0.5. So that means this is lazily evaluated. Now, because it's a lazy evaluation, you can check, because you can use something called next, and then or let's do this, x equal to, it will be z, next of x. Range object is not an iterator. What happened? Dot next. Attribute next. Okay. So sorry, because so this is not a generator. So the way to generate is like I x equal to I in for I in range 0, 5, 1, and the next of x, sorry, the next of x and next of x. So what I did here is because the range is no longer a generator now, it's a lazy evaluator. So first you have to create a generator for this, and then you can use the next here. So this is a change. This is the lazy evaluation method where but here you can see that I'm calling, like I'm iterating over range and calling method one by one. So that's why I'm getting this different element. But here in the Python 2, it's still a list, the full list. It's giving me full list. Now let's try this X range. Now if I do X range here, I get X range here. And if I, so in Python 2, the same thing, the whole trick that we did here, we need to convert this X range into generator. So I can say that X equal to, and create the generator. By the generator is created using, so you write the for loop, and then this is the expression to write to create the generator. I for I, so element in, then X range 0, 5, 1. So this will give you generator, and then you have something called x dot next. Now I'm going to show something really nice. So you can see here, I can use this x dot next and next here. So there are two way of doing the same thing, right? Now let's run this first. Let's try this here. So just right away say that, hey, x range is not defined, so you cannot do the x range. So x range doesn't exist basically in Python 3. In Python 2, it still exists. So in Python 2, you have range and x range. In Python 2, range will do list, x range will create the generator. In Python 3, range itself will create generator. It will act as an x range in Python 3, and there is no x range in Python 3. And now there is one more small change. As I told you about this next method, there should be always one and obvious way of doing things. So here you can see that you can do x dot next and next dot x, and both of them work fine, which is weird because why you want to have two way of doing same thing? In Python 3, if you see, we have this x, as a generator, and all I can do with it is next of x. I cannot do x dot next because this has been removed, deprecated. This has been removed from the whole Python 3 because we only need one way of doing things. We don't need two way of doing things. So that's why that is not exist here. So this is the common theme that you will see a lot, where there are two versions in Python. One is the lazy, one is so Python 2 lazy, non-lazy, and in Python 3 the non-lazy is converted to lazy, and the lazy version of Python 2 has been removed. And this kind of pattern you will see a lot in the whole this conversion. So now now we learned about this range thing and this generator evaluator thing. Let's go ahead and see next one. Okay, this is going to be fun. Dictionary. Dictionary is uh, most used data type or data structure in the Python. And as you saw that in the range, we have this way of iterating over certain list. So range will basically create the list and you iterate over list. Now in the dictionary is basically key value pairs, right? So dictionary has this inbuilt method using which you can iterate over their keys, values, and both. Key value is a pair. And in Python 2, we have this key value. So in Python 2, we can, when you want to iterate over keys and values or key value pair, you have this method called keys, values, and items. And all these are instant compute methods. Basically, when you say x.keys, it just create the new list for you and put all the, basically create the whole object with all the memory allocation, and x.key will be a fully usable object or a fully usable list itself. It will be instant compute. While x.keys in Python 3, it will be a generator, and because the generator, it will be some Python 3 will give you the Python dict keys generator, which is more like a wrapper around the keys, and same for the values. So if you see here, so let's try and see how things work. So first let's create this object called x. It has if you see 1 to 2, 2 to 4, 3 to 6. So this is the mapping, this is the key value pair, it's a square. So let's create the dictionary here and here. So we have Python 2 dictionary, Python 3 dictionary, and let's see how they behave differently for different keys, different methods. So first you want to do x.keys. With the x.keys, what you want to do is, it basically just give you instant value of all the keys, 1, 2, and 3. But while we are using the same thing in Python 3, so Python 3 give you the list. In Python 3, they give you like dict object. And just for the purpose, if you put it around, it's the same thing. We need to like add into generator. So the idea is it is not creating the, it is not giving instant values, but it is rather creating a generator. We can do the same thing here. Let's say p equal to x.keys, and then, p equal to generator I for I in, and then next of p. So again, the same way, because the iterator, you have to do it like that. And because in the Python 2, it just get you the all the values. So if you keep going forward, key values. So let's try values in Python 2 and Python 3. So in the Python 2, you can see that x.values will give you the full values, and in Python 3, it will give you some kind of yield kind of object on which you have to write the generator, and you can create the generator from this particular a class or wrapper method. And following the same key, so as you saw, I'm not going to do and run all of them just because I think it's going to be too much time. So just bring the value home. So keys, values, iterate items, Python 2, all instant compute. Python 3, there has to be an iterator that has to be created. And Python 2, which had their own version of lazy evaluated methods, they are now all gone. In Python 3, if you try to type them, it will just give you an error. So let's try this one just for the sake of it. So in Python 2, when you say x.iterate keys, it exists there, and it kind of like key iterator. So you can do like next, and then it will give, because it is already an iterator, it will give you an iterator here. But in Python 3, if you try x.keys, it just doesn't exist because iterate key is not defined in not defined in Python 3.0. So that thing has been removed from Python 3. So again, the similar idea that there has to be only one and obvious way of doing things, and let's favor lazy evaluation over instant compute, because lazy evaluation is performance optimized version. So that is one of the major change that we'll see, because a lot of people are using dict in their version. And if you are using if you have created this kind of if you have created items and you want to so because when you write the software, and if you have the old repository with Python 2, so many of them, you will have this for loop to go over the all key value pairs using x.keys, x.values. And at the time, it used to give you the whole whole list. But now, because it gives you iterator, it won't work. When you write x.keys and then you try to compile the whole thing with Python 3 and you try to iterate, it will give you an error. The similar kind of error that we are getting here, like, dict key object is not iterator, because you cannot do the for loop on top of that, because it's not the list, it's some kind of a wrapper object. So you have to change that. A very quick fix. So let's say you have uh, p dot keys, and when you say next of p, so because you cannot iterate on p, one of the very easy hack you can do is you can wrap it around list. And what it will do is, basically list will basically force p to iterate over all the items and create the list. So let's say you are trying to convert your Python 2 to Python 3, and you have this this thing where you are doing this command, x.keys, you are iterating over x.keys, which works very fine in Python 2. So you have to just write to convert the whole code, to make the code to work in Python 3, you just need to do this. You just have to like add the extra list around it. So wrap it around the list, and it will just behave like a Python 2. So if you want to you want to use x.keys and you want to get the list in Python 3, you just wrap around the whole thing into list in Python 3. So it will give you the list. Let's move ahead. Oh, okay, this is the big one. So division. If you know in Python, the default behavior in Python when you try to do the division is it will it will not do the internal internal type conversion. So it will not do type conversion, and so integer divided by integer will be integer, and it won't be float. But if you that is a default behavior, and if you want to so that behavior has been changed in Python 3. So in Python 3, when you divide to integer, and if the result can come into float, it will be in the float. So let's try it again. So in Python 2, when you say 5 divided by 2, so it will only give you 2. It will drop all the decimal points, because integer divided by integer equal to integer, and integer doesn't have decimal points. So that's why you get this. But in Python 3, if you have some code where you are trying to do, x divided by y, and somehow x and y both are integer, the result will be in integer in your Python 2. But in Python 3, if you try to do x divided by y, you will get decimal point. So because x divided by y will try to convert and create the float value. So this is one of the bigger change, because your code is expecting to work with integers, but now it generate the floats. And let's say you are iterating over some number over the 2, you can iterate over 1 2 3 4. You cannot iterate over get me index I of 2.5. That is not work. I of 2 will work. I of 2.5 will not work if you're doing the indexing to use this number. So all these kind of error can come in. So if you have any kind of division operation, and if you want in the Python 3, if you want to achieve the similar behavior as Python 2, you have to do this. So if you want to transit from Python 2 to 3, and want to make sure that your Python 3 behave the similar way as Python 2, all the division operation has to have this double slash. So this is one of the change that Python 3 has. Because it makes sense that because if you're coming from different programming language, you have seen this behavior that the division operation will always give you float when you're trying to do something like that, integer divided by integer. If there's a float value, it will give you float. It will not give you integer if natural output is a float. And that is something they wanted to fix, and that was a wrong decision being made in 2.0. So to fix that, that is how they come up with the idea that, hey, because now we do not have this package of making sure that the code is backward compatible. We can achieve this because we told that, hey, what are going to work on Python 2 will not work on Python 3, so be careful. So because of that, I can do all kind of changes in Python 3 without worrying about what will happen in Python 2, because Python 3 is a new design, and this is one of the new design. So this is possible because they break the backward compatibility, and that's why we see them. Okay, so now one of the example which I talk about this before. In Python 2, taking an input from user. So when you are dealing with the terminal and you want to take an input from user using terminal, there are two ways you can do that with Python 2. First is raw input. Raw input will basically, when you type raw input, it will just take a string and it just process the string and give you the output. And in Python 3, let's not talk about Python for Python 2. Raw input for reading string, input to read the expression basically. So it will read the expression, evaluate the expression, print the expression. What is the expression? A plus B is the expression. 2 plus 5 is the expression. Or, hi plus hello is the expression. So these are all expressions. These are not strings. So when you say input, by default, Python 2 will assume it as an expression and not as a string values, but which is very weird behavior if you're coming from different programming language, and the raw input will do the whole the string thing. So this is a bit confusing, bit ambiguous for someone who is new and someone coming from different language, and someone is trying to read the code. So in the following changes, what they did, they get rid of raw input in Python 3. That hey, there is no raw input, and in Python 3, everything that you read using input will be string. So they deleted raw input from Python 3 and kept the behavior or move the behavior of raw input into the input. So now input will do the string reading and not raw input. We are already 7 point, sorry, so time is running out. So I'm gonna go a bit quicker about a lot of these things. I'm not gonna type each and every code, but I'll try to explain all the topics. So just to cover maximum topics. This is one of the biggest change that came into Python 2 and 3. I think one of the most notable change, strings, how Python 2 and Python 3 handle strings. And so Python 2 internally store its string as an ASCII character. So when you type A, so whatever the 7-bit numerical ASCII representation of A will be used in Python 2. That means because it's a 7-bit an ASCII character, it cannot deal with the Unicode, right? So in Python 2, they started with, hey, let's do the ASCII, and the string is internally stored as a ASCII array. Hey, but now we have to also deal with Unicode. So what we do, let's create the separate Unicode thing, and there is no subproof byte. So Python 2 had this idea that string are ASCII array. And if you want to deal with the Unicode, you need Unicode, because if you want to deal with different kind of a language, let's say you want to write something in Russian, Hindi, or Cantonese, or Japanese, any language you want to, which is not non-English, or let's say you want to use those smileys, those emojis. So all those things are not possible in the typical string. You have to use this special thing called Unicode, and so many times. So the problem is that many times you are writing a code which is designed to deal with the string. Okay, I am developing this chatbot, and I'm going to use this string to read the data from the user and send the data back and forth. Now, because it is a string, if someone is trying to send the smiley and use that that Unicode smiley character, it will not come up as a smiley, because my Python doesn't understand Unicode, because I'm using the default string method, and I have to make sure that string and Unicode and everything makes sense. Everywhere I write the code, everything has to be Unicode. So it's very jumping. So jumping between default string and Unicode was very complicated, because you need to think about, hey, I wrote this whole this software with the string in my mind. Now my customer is start typing Unicode methods, start typing in Chinese, started typing all these all these smileys, and things are breaking because my the way I handle this data type, it doesn't support Unicode. It's a string, so it breaks now. So all these problems are coming in. So they were like, we need to fix this, and we need to make sure that strings are Unicode by default. So in Python 3, every string that you store in backend use Unicode. So when you type something in smiley emoji, everything is now possible because Python 3 has now Unicode. It does all the Unicode thing. So in Python 2, how you differentiate or make the string Unicode? Either you use this Unicode as a Unicode method that you can see here, or you type your string inside this Unicode method, or you do something called u dash. I'll show you later. something like u dash and then string and this. So this u says that this is Unicode and this is not a typical string in the Python 2.0 or 2.x. In Python 3, everything that you write is Unicode. So you can write all your smiley emoji, everything will go fine in Unicode. With the string, you don't have to do anything extra. You don't need to worry about Unicode problem or breaking things because the Unicode is not supported. So that was the major change. And so if you are writing Python 2 and you are trying to make all these Unicode compatibility, so you write everywhere you want to store something or use something as a Unicode, you try to use Unicode as this Unicode method or u dash and then write your string. Now in Python 3 you don't have to do that. Whatever you write here, any crazy character, it will be all converted as Unicode. It will all be accepted in Python 3. And because Python 3 take a string, it initially stopped taking this as a valid character, and people are complaining that, hey, why this is erroring out, and they added this dummy u. So basically in Python 3 also you can do this like u and this thing, but u doesn't do anything. It just for the sake of backward compatibility for some people who are trying to port from Python 2 to 3. If you type u this, Python 3 will still recognize as a regular string, and if you write this, Python will still recognize a regular string. So if you are writing Python 2 code and if you change to Python 3 and you have written your Python 2 Unicode, u dash thing, you don't need to worry about this because Python 3 will support both of the format. So this is the very, very important concept that we need to know when you are trying to go from Python 2 to 3. So this is an experiment. I'm not going to run the code. You can run the code by yourself, but you require. So if you see here, this is the some random Unicode character which I picked it up. So in Python 2, when you type like this, it says string. In Python 3, everything is string. There is no separate Unicode. So in Python 2, you have to make the Unicode to work it. So when you try to do the Unicode operation on two Unicode methods, so you see this weird kind of thing because the addition operation is not defined on this Unicode type. But string plus is defined on string. So string is just concatenate whole thing, but plus is not defined on Unicode. So that's why you see all this, weird thing. So the whole idea is, this could break, right? If you're trying to merge two Unicode in Python 2, it will come out like this, and it will be weird way to represent. So you can still do print and it come out well, but the idea is the Unicode might break something, but because everything is string, you can be relaxed that nothing will break when you are using Unicode. So that is the advantage of using Python 2. Now, those who are slightly advanced user who use exception in their coding. So there are two ways to do exception in Python 2. First is raise exception and comma, and then you write whatever message you want to say, hey, my thing like, like say raise arithmetic exception, comma, you can't use division on, by 0. You can't do divide by 0, let's say. So you can do like this, or you can do raise exception, and in the bracket you can do like this. So this is like kind of expression, and this is a method. So same as a Python, as a print statement. Python 2 supported both of them, but Python 3 said no, I don't like this, I don't want to do this two way of doing things, so we're just going to support one thing. So if you use this in Python 3, it will fail. You must use raise exception and then opening closing bracket as a raise exception as a method, and then use the Python 3 on top of that. Now if you see here, one more thing that you can also do like raise exception comma e, so it will capture your exception here using comma, but instead of comma now you have to use as. So comma and as were supported in Python 2, but in Python 3 is only as, you cannot use comma. So this whole use of comma has been removed from Python 2, and from Python 3, and it is only in Python 2. Now this is something which I showed you earlier, that support for there are two way of going over iterator, next and something, or something dot next. So something dot next, sorry, this was my mistake. We support next, and Python doesn't support dot next method, so that has been removed from the Python. So so from the X you can do like this or like that. There are two next method, but in Python 3 they say that, hey, we only need one way to do things, and because next of X has been most widely used method, so they say that we're going to keep this and we're going to get rid of this one. So that is one of the change in iterator and next method. Now this is something very weird that can cause an error. So let's say you have the global variable called I, and you have value 1. Okay, and now this I you are using somewhere locally, and this is local. This is a for loop, so you are using I inside the for loop. So locally you are using the I, and because this range, so I will be modified. Now this is a global, this is local. And even though it's a local, it will still modify the I. Let's just quickly do this example. It will be quick but very interesting. So in Python, to what happened? You have I equal to 1, which is a global, and then you take something local. This is a for loop basically. So it's a I inside the for loop. So now my I has modified because of that. And when you do I, so I although I is a global variable, but global variable was modified by local variable. So this is a leak. This is a problem. But in Python 3, that has been fixed. So you can do like this, and then here is a local I, and then again you do like this. So I is retain is so global I retain is global values, and local and using I as a local variable doesn't change whatever the global leak was. So this was something a global leak, which was a problem. So that has been fixed in Python 3 now. One more thing, this is also very useful. This doesn't apply to equal to, not equal to, because equal to, not equal to are, it's either or not. Try to compare things, but when you have like greater than, less than, when you're trying to check the order, you have two list or two iterable, two object, and you are comparing them, and there has to be some sort, and there is no natural order to compare them. So one is an integer and one is a string. There is no natural way to compare them. There is a tuple and there is a string. There is no natural way to compare them. They're both very different type. In Python 2, somehow this worked, but in Python 3, now this will give you type error. So in Python 3, when you try to do some kind of order checking, greater than, less than, greater than, equal to, less than, equal to, all those kind of, uh, except equal to, not equal to, anything that has anything that involve either greater than or less than, it will do type checking. And if type doesn't match, it will just throw type error. It will only do the order compared when there is they both are compatible type, and not when there is no natural compatibility or ordering between two objects. Uh, so this is one very good advantage in Python 3. Now there's some syntax that has been removed. One of them is tuple parameter. So tuple parameter unpacking. So what happens when you say func a comma then pass b comma c, this will technically behave as a comma b comma c. Now because a comma b is being tuple being unpacked, so this unpacking is not possible. Now this will throw an error. In Python 2, we have very not so being used, unequal sign. Very few people know about this. This is also another unequal sign. So you can do like, 1 not equal to 1, so false, or you can do not equal to 1, that is false. But in Python, you can't do that. This operator, which is equal to, not equal to, is not allowed now. So, the only way of doing this is like not equal to 1 or I equal to 1. So the idea is this whole operator has been removed from Python 3 now. It is not being used. Very few people know, and very few people use this unequal sign, but that is gone now. Now a lot of people remember in Python there has to be like, there was a long and there was an integer. There are two types, and when there is a long data type, you have this L, small l, capital L. Otherwise, there is nothing. Now that is all gone in Python. Everything is in backend. Everything is long. You don't need this L as an indicator whether it's a long or integer, because there is no longer there is only integer now in Python 3. There is no long, and new integer in Python 3 is a long. So basically internally it's a long. So you don't have to worry about the range of the integer. Now the range of integer has been increased. Same for the string. This support for u and u no longer supported. So basically you can still type u and u. They are dummy. That doesn't do anything special. And as I told you, it's a Unicode support for that is there, but there's no Unicode issue with the Python 3. Now following is not supported inside functions. So from module import star, so you cannot write this thing inside the function. When you say writing def something and you try to import something in the def because you want to avoid some kind of circular dependency problem, that is not possible in Python 3 now, because Python 3 force you. So that circular dependency came because of this relative import. But when you in the new Python, when you're trying to do relative Python 3, when you try to do relative import, you must use dot. So you cannot do like from module import star. So from module import star will try to look into your relative path, your neighbor module in the same level, but that was confusing, and that caused circular dependency problems that I'm calling you and you calling me kind of problem. So it was like weird. So to get rid of all that, they say that, hey, if you want to import something from the neighbor same level dictionary, you have to use something called from dot, and that will give you something from the same level thing, like if from your neighbor or from the same level module. And because of that, now that there is no circular dependency issues because of introducing of this dot for the neighbor modules. They get rid of this whole idea of you need to like import the module inside the function. So they first get rid of the core issue with the function. So they also get rid of the workaround to solve that issue in the function. So the workaround was when you have circular dependency, the workaround was importing the module inside the function. But they say that, hey, we remove the core issue, so also we're gonna remove or restrict to do that workaround thing. So that's the whole this 2 point. Now, what is added? So this is fun thing which is added, which is very useful. Extended iterable unpacking. So what is that? So this is the object that you want to unpack. So you have A, B, and then star rest. So what we'll do? While guess, one will go to A, two will go to B, and rest will go to star rest. And now star rest will have all the leftover. You can also do something like this. Maybe I can just quickly demonstrate this. So this won't work in Python 2 because Python doesn't support that. In Python 3 this will work. So A, B, and rest. And then let's say I change the syntax a bit, and I can say, let's say, comma B here, and remove this here. A, B is the last, and the rest will have the middle element. And you can do all kind of fun stuff, like you can say C, comma A. So now 1, 2, so A, C, since rest has only one element because it's still a list, so you can see there is a list, and then B. So this fun unpacking thing is there. No local statement. So there is another way. So you have like this you have this value of X, and this X is so it's not global. Global is like on the top level, but you have, let's say, multiple level of hierarchy, multiple level of nesting, and you want to make sure that when you're using something inside one nest, let's say for loop in for loop, so that for loop inside the for loop doesn't cause the problem. For I equal to something, and then again for I equal to something can cause the problem. So to get rid of that issue, there's something called non-local that will make sure that it doesn't get leaked to the outer scope. Also, as you know that in the string there is a new byte has been introduced as one of the string kind of data type. So there in the Python 2 there is a string, ASCII string, and there is a Unicode, but there is no support for bytecode or byte. But in Python 3, the whole the ASCII and Unicode is only Unicode, and now there is a support for byte. So there's a byte and byte array, so you can deal with both of them. This is a very fun thing, keyword argument, which on the interest of time I will not discuss it, but this is basically cause. So let's say you are passing 1, 2, and 3, okay, and like this 1, 2, and 3. You are not intended to pass 3 to the option equal to true, but by mistakenly you pass that. You can prevent doing like that, because what this will do that this will tell that if you want to pass, when you pass 3, the 3 will be observed by star, because if you want to really do the option 1, you have to say that option equal to something. So when you say f1, 2, 3, so in Python 2, when you type 1, 2, 3, f1, 2, 3, 1 go to A, 2 go to B, but you don't want it 3 to go into option. That was a mistake. So when you put star here, the 3 will be observed by here, and that will get rid of that mistake, and then that will not have let you make that mistake. So 1 is here, 2 is here, 3 will be observed by the star as a sanity, and then sanity check. And then if you really want to work with the option, you have to forcefully apply the option equal to true. There's also some sugar coating, syntactic sugar in yield from. So there used to be like for I in generator yield I. That is how you used to write yield for I. So there's a method that will give you this generator. So instead of for I using this for statement, you can just say yield from generator. You don't have to do for I in generator and then yield I. You can just say, so instead of doing like this, yield I for I in generator or range or whatever, instead of doing like this, you can just say yield from generator and you will get the result. So that is the whole deal here. Now there are new other libraries being used. Fault handler. Fault handler will basically help you if you, let's say, if your program crash. So what happens if your program crash, then you can't really capture the error message, because exception E has to print something to capture what went wrong or what was the exception. Exception has to be print. Or something fail, crash, your exception will not be executed. So you will not be able to, you will not have a chance to print your error if your program crash. Using fault handler, you can do that. You can import a fault handler, and even though your program crash, you will get the error statement. So that is a fault handler. Another thing, IP address, a nice way to parse your IPv4, IPv6 IP address. So you just say that. So because so no, so the idea is that you have this extra IP address library, so you can just pass your IP address string. It will do all kind of validation, all kind of other funny stuff. You pass IPv4, IPv6, it recognizes them differently, and then behave or act. You can do different things with IP address. So very fun way to use IP address instead of writing your own sanitizer or writing your own methods around IP address. Enum. Enum was missing from Python 2. So Python 2, people still use enum, but that was more of a workaround. Now with Python 3, you have enum as a very how I say that, a native enum inside your Python. So that has been introduced now. So enum, as you know, that enum is kind of like a way to define your custom data type, or the way to define a variable which can only have certain values that you define. And so let's say I want to create an enum of fruits. So when I'm trying to store the fruits, I can only store the fruits that are defined in my enum. If my enum has let's say banana, apple, and mango, I cannot, and my data type is enum for that fruit. So that particular variable of type data type enum cannot get any of those other fruit which is not part of that enum. So kind of like creating the limited values possible for that particular variable. So that is natively possible now in Python 3 using with enum. So that was a missing thing that came in. There's so many other cool stuff. I'll just go click over. So there is some numerical improvement. So this is a number, but let's say you want to have some numeric clues. So you can say that 85 underscore 0, 0, 85 underscore. This is basically means 85,000. But this gives you nice visual clue that, hey, this is like 85 and then 3 more 0. One more thing, it's called Python string interpolation, being used a lot. So within the Python, you can define an expression. People who have been using Jinja template or any kind of templating language or something like that, they are aware about this. Within the string, you can create this kind of like curly braces and write the expression, and the string will consider this as an expression, evaluate the value, and then print that. Same thing here. F, you write the string. Inside the string, you write this kind of funky expression within your curly braces, and whatever expression you write here, it will be evaluated and it will be resulted. So this will be printed as this is a Boston city because city will be evaluated with the Boston. Also, there's type annotation. Python is dynamically typed, but you can force type annotation. It's not like you cannot x will forever be integer, but more like giving a visual clue that, hey, this x is taking integer. So when you say x int equal to something, so you can only type here number, you cannot type anything else. But once you have x int equal to 5, then you can say x equal to integer, sorry, x equal to my name, and that will work fine. Also an implement or OS library. So os.scandr, we do a lot. People who are dealing with the file system or using Python to deal with the dealing with the lot of administrative work or reading the file. Like reading the files also we do a lot. So within the directory you want to get all the files. So we already have os.walk and os.scandr basically do all kind of improvement, make it faster. So it works really fast now. And sorry, we are going way above the timeline, but this is the something. So we saw all this cool feature. Now, let's say you have Python 2 project, you want to move to Python 3, how to do that? Like what are the challenges? Basically, there are 3 approaches that people take, and I'm just going to talk about like very briefly. So first approach is just change your compiler, just start, change, like when you're compiling your whole project, stop compiling using Python 2, start compiling using Python 3 and fix whatever error comes into the way. This is possible for very small projects, single person project, very, let's say, a couple of files and not too big of a project. It's easy to change because it's not too much difficult. Now, problems start when you have enterprise software, multiple release cycle, a lot of people using it. You're using thousands of libraries to do that. And then there are 2 ways you can really keep supporting 2 versions. You can migrate to Python 3. So you have these customers who are using Python 2, different versions of Python 2, and some people who want to use Python 3, different versions of Python 3. So what you can do is you can maintain 2 separate repo, one for Python 2, one for Python 3, and then you keep like, making changes into both of the libraries and gracefully deprecate your Python 2 repo. So let's say my cool project. So you have my cool project Python 2, my cool project Python 3, two repo you maintain for two different compiler and keep adding the code and maintain the code separately, which is very weird because every time there are two places of you want to make the code that goes two places is always difficult, is always weird. Maintaining two copy of same thing is it's really complicated stuff. So that is one of the way people do that. If you don't have very big code, the third approach, which is being used a lot in industry, what they do is they have this Python 2 friendly code, which is not friendly to Python 3. What they do is they make the code Python 3 friendly by using something called 6. 6 is a library which allows you to, so as you saw here, there are some methods that were friendly to Python 2, not to Python 3, and then friendly to Python 3 but not to Python 2. So what you can do, all you can do is all those methods which are like different between Python 2 and 3, you use 6 to use basically 6. What 6 basically does that, let's say if my version, imagine 6 as as a wrapper around your let's say iterator. So when you use when you want to, let's say, define the loop, you say that for I in 6 dot range, and then you do. Now what that does, that if you are running that code in the Python 2 environment, it will behave as a Python 2, and when you're running in a Python 3 environment, it will act as a Python 3. So the idea is you are writing a software that will run in both Python 2 and Python 3, although they both have a same syntax. The biggest difference between Python 2 and Python 3 is syntax different, right? So what their 6 does is, if you understand 6, 2 cross 3, smart, 2 cross 3 is 6. So what they do is you change your code in a such a way that the code remains same, but it will compile in Python 2, Python 3 with the same behavior. So 6.range will behave same in Python 2 and Python 3, and compile in both Python 2 and Python 3, although Python 2 has a different syntax, Python 3 has a different syntax. Once all your customers, all your code, everything has moved to Python 3, then you can get rid of this 6 and then change everything to, the by default Python 3 way. And by default, and every time you try to push your code, make sure that, so you don't allow new code to be Python, not Python 2 and 3 friendly, and finally get rid of the whole Python 2 code. So that is the last has been used the most in a big industry corporate enterprise software, because you have customers running Python 2, you have customer Python running 3, you have to support both of them. Maintaining two repo doesn't make sense, it's very complicated. So you just change everything to 6, make them compatible with 2 and 3 at the same time. So you have same code, one source of truth, acting similarly, and compile safely, either you're doing Python 2 or Python 3. So that is what 6 provide. So you can use 6 to do that migration. So at the end, the conclusion, as we saw that, Python 3 does a lot of things. When you go to 2 to 3, so many things are coming change. Existing syntax are changing its own behavior. There are things that are getting deprecated. There are things that are being introduced as a new, and a lot of these, Python 2 methods or Python 2 expressions has been converted from instant compute to lazy evaluation. So that is something new. And we always know the software release and maintenance cycle is hard, and making everything compatible, making sure that your backward compatibility is there, and also performance improvement, making all these kind of changes. When you want to do behavior change is very, very critical, because it's hard to track how many people, and Python as a software which is embedded into all the Linux operating system, it's really hard to change them. If you want to keep doing Python 2.6, Python 2.7, and Python 2.6 has your range as a instant, and Python 2.7 has your range as a generator, because when you do generator, you have to retype everything. So it kind of break everything. So it's really hard to do all these kind of changes. If you want to bring the behavior change, you have to break the backward compatibility. And to break the backward compatibility, they need the Python 3. So it's clear that the message is clear that this is not Python 2, this is Python 3. Syntax are different. It's going to behave different. So don't compile a Python 2 with Python 3, or be careful with that. So that is the whole thing. And this is all the references that I used for preparing this presentation. Thank you very much. As always, I promised to complete on time, but I never. But I really appreciate you guys sticking around with me till the end. And as again, if you have some feedback, you can leave the feedback on our Meetup channel. Also, if any of you want to come and talk about one of those things that you are interested in, look, I'm not a Python expert. I do my own research, I learn about things, and I do the presentation. like any student who would do presentation in their school, in their uh, they learn things over their semester, and then they do the presentation at the end. So you guys can also do something similar. Either you are doing something fun you want to share with the other people, either you're learning the Python and you feel like, hey, I have learned this thing, I want to just do some quick presentation to the people who are also learning with me, just to form the community, serve the people. So I'm saying that feel free to reach out to me, and don't be shy away from doing this kind of presentation. I didn't know a lot of things. I learned a lot of things by while making this presentation, and continue doing that. So again, thank you very much, and I hopefully see you soon. And have a rest of the good night, you guys. It's probably 8. I hope everyone is Boston. So 8 p.m. Have a good night, guys. I'm gonna close this presentation. Thank you very much for joining again. Thank you.